So here we have our equation. 2 shoes plus 1 girl gives 1 girl with shoes on. Notice that the equation gives the ratio. It doesn't mean that in the world there are only 2 shoes and 1 girl who get dressed and end up with 1 girl with shoes on. No, it means that throughout the world when girls get dressed, they need 2 shoes for every 1 girl. So if there are 30 girls, we need 60 shoes. If there are 100 girls, we need 200 shoes, and so on. It's a ratio. We've already seen that this is the format of the particle ratio. 2 is to 1 is to 1. And we've already done the mass ratio, but let's quickly do it again. 2 times the mass of 1 shoe, which is 0,2 kilograms, is equal to 0,4 kilograms. 1 times the mass of 1 girl, 1 times 50, is 50 kilograms. 1 girl with shoes on, 50,4 kilograms. So here we have a mass ratio. 0,4 kilograms shoes is to 50 kilograms girls is to 50,4 kilograms girls with shoes on. So now which is the limiting reagent? We've already spoken about this definition of limiting reagent, the reactant that runs out first. And we saw that the girls run out first before the shoes do. There's still 1 shoe left over. That means that the girls are the limiting reagent. So they will also produce fewer products, girls with shoes on, if all can be used up. And they will determine the yield of the products. Let us examine this definition here, because this is the one which tends to be the easiest way in chemistry to find out which is the limiting reagent. So remember, in our story, we have 7 shoes and we have 3 girls. Now we want to find out which one will produce less if all is used up. So we ask ourselves, first of all, how many girls with shoes on, that's the product, how many girls with shoes on will be produced if all of the 7 shoes can be put on? So let's answer this. Obviously, there's an easier way to get to the answer of the limiting reagent. We've done that already, but we're doing this so that we can see the method and then be able to apply that to more difficult chemistry problems. So how many girls with shoes are produced if 7 shoes are all put on? So we need a reaction ratio, which acts as our conversion factor. This is the question, and here we have our conversion factor. We get the conversion factor from this reaction ratio over here, and we must write it in the format that has girls with shoes on. That's just my shorthand for girls with shoes on at the top and shoes at the bottom. And we know that 2 shoes are always associated with 1 girl with shoes on. So we calculate 7 divided by 2, 3,5, which is obviously ridiculous because you don't get half a girl. But we can think of it as 1 girl has only half what she needs on her feet. So if all 7 shoes can react, you'll get 3,5 girls with shoes on as your product. What about if all 3 girls can react? Remember, in our original story, we have 7 shoes and 3 girls. So, how many girls with shoes on are produced if 3 girls can react completely, in other words, can all get shoes? So we have our question here. We need to multiply it by a conversion factor, which comes from the ratio of the substances. And girls need to be at the bottom, cancel away the given unit. And we know that 1 girl reacts or gets dressed to produce 1 girl with shoes on. So 3 times 1 is 3 girls with shoes on. So we saw that if all 7 shoes can be put on, then we'll end up with 3.5 girls with shoes on. But if all 3 girls can get shoes, then we end up with 3 girls with shoes. And clearly this is the smaller one, and so it is the limiting reagent. So we can find the limiting reagent by doing a process like this, and the reactant, which gives fewer products, is the limiting reagent. So let's answer question 3. From these calculations, we see that the limiting reagent is which one? Girls, because they will produce less or more? Less of the product if all of them can be used up. So obviously now we need to apply this kind of thinking to a reaction with some chemicals, not just girls and shoes, of course.